The last part of a regulated DC power supply is the voltage regulator, which is used for maintaining the output voltage of a power supply at a constant value. So, the mainly used voltage regulator is the Zener voltage regulator. So, we know that the Zener voltage always operates at the reverse breakdown region. We have already studied the operation of a Zener diode. The Zener diode is designed to operate at the reverse breakdown region. So, if this is the reverse breakdown voltage, the diode undergoes breakdown at this point and the current increases rapidly. So then, after the breakdown, whatever be the magnitude of the current, the voltage remains constant at its reverse breakdown voltage. So this property of a Zener diode enables it to be used as a voltage regulator. If the Zener diode is operated in its breakdown region, its voltage always remains as a constant value, irrespective of the magnitude of current flowing through it. So this property, due to this property of a Zener regulator, this can be used as a voltage regulator. And the Zener diode is connected in parallel with the load. So a Zener diode or a Zener voltage regulator is used for keeping the output voltage of a regulated DC power supply constant. So there are two cases due to which a variation can happen in the output of a regulated DC power supply. So one is the change in input voltage and another one is the variation in load resistance. So the output of a regulated DC power supply may vary due to two reasons. They are changes in the input voltage and the changes in the load resistance. So a Zener regulator has to provide voltage regulation, or it has to provide a constant DC voltage under both these cases. And the regulation when input voltage is varied is known as line regulation, and the regulation when the load resistance is varied is known as load regulation. So first let us see line regulation. So this is the circuit diagram of a Zener voltage regulator, which provides a constant output voltage across the load. So here RS is a resistance which is used for limiting the current flowing through the circuit. So here the condition is there is a variation in the input voltage. So input voltage is variable and the load resistance is fixed. So here IS is equal to IZ plus I0. The current IS is equal to IZ plus I0 and voltage across the load resistor, that is output voltage. So we know that according to Ohm's law, V is equal to I into R. Therefore V0 is equal to I0 into RL. V out is equal to I out into RL. So here we are considering that the load resistance RL is fixed. RL is fixed. So we need a constant output voltage. So as RL is constant, for V0 to be constant, I0 should always be a constant. So from this circuit diagram, we can write I0 is equal to IS minus IZ. I0 is equal to IS minus IZ, and we have to keep this I0 a constant. So consider two conditions. Suppose there is an increase in supply voltage. What will happen? If Vs increases, Is will also increase. So if Is increase, there is a chance for I0 to change. So in order to keep I0 constant, we have to increase Iz also with increase in Is. So another condition is a reduction in Vs. So when Vs decreases, Is also decreases. So when Is decreases, there is a chance for I0 to decrease. So with the reduction in Is, we have to reduce Iz also. So this is how line regulation is achieved by a Zener voltage regulator. So next case is the load regulation. That is when there is a variation in the load resistance RL. So here we are considering that the load resistance RL is variable and the supply voltage Vs is constant. So same as in the previous case, the output voltage will be equal to output current into resistance value I0 into RL. So here we are considering that RL is variable. So we need to get a constant output voltage from the voltage regulator. So as RL is variable here, we have to correspondingly vary I0 in order to keep V0 a constant. So here also there are two conditions. Suppose the value of load resistance RL decreases. So if RL decreases, there is a chance for V0 to decrease. So we have to increase I0. I0 should increase. So for getting a higher value of I0, we have to reduce the value of Iz. So reduce Iz. And if RL increases, what will happen? V0 will increase. So in order to keep V0 constant, we have to reduce the value of I0. So I0 can be reduced by increasing the value of Iz. So this is all about load regulation performed by a Zener voltage regulator. Thank you.